So welcome. Today we're going to be talking about how to set up a split flow mesh using Code WAND. Begin by kind of going over an introduction of what we mean by split flow. We'll look at some of the prerequisites for generating this type of mesh. Then we'll look into the actual process from a high-level perspective before we kind of dig down into the nitty-gritty details. And then we'll look at actually executing that simulation. So when we talk about split flow, the splitter feature from split flow is what we find in a turbofan engine that's actually splitting the flow between the core path and the bypass path. When we're generating this splitter mesh, what we want is to couple the simulations of the fan, bypass, and the core flow, and to also accurately model the effects that the splitter geometry is having, so that we can get a good prediction of the true bypass ratio of the engine. So in our kind of conceptual turbofan engine, we're going to break it down into four primary sections. The first section is the fan blade mesh. The second section is our split flow mesh, and you can think of this as the glue that holds together the fan blade, the bypass, and the core flow. And then we have the bypass flow up here, and then the core flow. Now, in this case, for the bypass and the core flow, we're really only interested in the first row, beyond the split flow mesh. You can see in the cartoon here for the core flow, we may have many rows behind this. But for generating the split flow mesh, we're not really concerned about that. We just want to focus on the rows immediately after. So in order to generate this mesh, what do we need? So we need to already have generated meshes for the fan blade, the fan exit guide vane, or whatever you have in the bypass, and then the first row for the core. So these should be generated in WAND on their own. You'll also need a description of the splitter geometry, and we'll go into some detail of what we mean by that later on, as well as a description of where the interface location should be located for the fan blade, the bypass, and the core. And those interface locations should be consistent with the meshes that we already generated for those rows. So when we generate the WAND meshes for our other rows, there will be some data files that come out. You'll see it'll have the name of the row. In this case, we're calling this fan, and it'll be both -dw.data that represents the downstream or the exit plane of that mesh, and the .uw or the upstream or inlet row of that data. So you can see for the fan, to interface with the split flow block, we're really interested in this downstream data. And that's going to inform the mesher about how the grid is distributed in the fan mesh, primarily in the radial direction. Similarly, for the bypass and the core, we're interested in the upstream data, since that's where the split flow block will interface with those rows. And again, these files communicate to the mesher, how the radial mesh spacing is distributed. And again, the names of these files will be dependent on what the names that have been given to those previously generated meshes are. So they won't necessarily just be fan, bypass, and core. Whatever they're named is up to the user. So here we're just looking at when we generate our meshes initially for the fan, the core, and the bypass, what goes in and what comes out. So to generate those meshes for an input, we need a .wand file and either one or more AGF files. Those go into WAND, and we get out our restart files with the mesh. But again, we also get out these upstream and downstream data files. And these are the files that will go into the the split flow generation process. Now, here we've defined 3 sets of end walls. We have the hub end wall, shown by the blue curve here. We have the shroud end wall, shown by the red curve here. And then we also have the splitter end wall. So this is the the definition or description of the splitter that we spoke about earlier. So this has 2 purposes, actually. One, it will describe the splitter for generating the split flow block. And it will also be used to generate the hub or the ID end wall for the bypass, and the shroud or the OD end wall for the core. When putting this definition in for the later on for the splitter AGF file, you'll put in this entire definition. However, when using this for the bypass and the core, we want to basically cut these in half. So we only use this bottom section of the splitter definition for the shroud end wall in the core, or the top half for the hub end wall in the bypass. But the important thing is to make sure that when we specify either the hub or shroud end wall, we make sure that for any given value of x, there exists a unique value of r. So what we want to avoid is, say, cutting it, where it loops back around here, so that maybe for this value of x that we have 2 or more values of r. So the other thing that we have to define is the split flow control points. And this tells the mesher where the interface between the split flow and the adjacent rows is going to occur. And again, these locations should be consistent between the meshes that we generate in the beginning for the fan, the bypass, and the core, as well as what we tell the split flow meshing process later on. So, obviously we need an ID and an OD location for the fan, the bypass, and the core at the downstream for the fan, and then the upstream for the bypass and the core. So getting into some of the more nitty-gritty details, this is what the WAND setup file is going to look like when we generate the split flow mesh. And again, this is assuming that we've already gone through and generated the 3 meshes for the adjacent rows. And so we want to, the key here is we want to set the input type to 7, the output type to -4 for this first row. That's going to tell WAND, how we are setting up the that it's going to be setting up the split flow. In the second row here, what we're telling WAND is how many points we want around the splitter leading edge, and the number of points in the circumferential direction for the split flow mesh. This third parameter should just be set to 1. In the next row, we're looking at the number of points upstream of the splitter leading edge, followed by the number of points downstream of the splitter leading edge. So you can think of this as, this one controls the number of points between the splitter leading edge and the interface with the fan. This one controls the number of points between the splitter leading edge and the interface between the core and the bypass regions. The next parameter controls the number of K-planes that will be generated in the core section. This parameter should be set to 1, and then this final parameter in this row is the number of K-planes for the fan section. So these two should correspond again with the mesh that's already been generated for those rows. And if you're wondering, where do we put in the number of K-planes for the bypass. We'll go into that in a moment. So here, for the next row, end file should be set to 4, or set to 1, sorry. The iplot, this can be set to whatever you want for a plotting output, and then as well as the number of iterations for whatever you want. So here's where we kind of inform WAND about how the number of bypass points. So we can't just set arbitrary numbers of K-planes for the core, bypass ratio, and fan. Since we're running since this is a multi-block structured mesh, those numbers are somehow interconnected, and they're related by this equation right here. It's pretty simple. So the sum of the number of core and bypass K-planes minus the number of fan K-planes should be equal to the number of I-planes. That's this thing right here that we mentioned earlier. It's the number of points around the leading edge of the split flow plus 8. For the final section of the WAND setup file, we're telling WAND where the AGF file for the split flow is located. Now the next row, this is going to control how we do the matching. So in general, you want to do full matching between the fan, the core, and the duct. If you have a special case where you don't want a radial match between either the core and the bypass or the duct and the bypass, you can set that. But in general, we should match all of them. And finally, we point to the data files for the fan downstream portion, the core upstream, and the bypass upstream. So moving on to the AGF file, the first 5 rows are pretty standard for an AGF file. These can all be all these parameters are described in the WAND technical reference. Now, moving on to things specific for the split flow, we need to define those interface locations. And so there are 6 locations that have to be defined. We have the fan downstream OD location, fan downstream ID location, bypass upstream OD location, bypass upstream ID location, core upstream OD location, core upstream ID location. So these have to be placed in specific points within the AGF file. So, once we get past these kind of standard inputs, the first row after that is going to be our fan interface location. So there's 4 parameters here. We have the X position for the fan exit ID location, and then the R position for the fan exit ID location, followed by the X and R components for the fan OD location. Next line, we have the bypass X and R hub location, and then the bypass X and R tip or OD location. The line after that actually gets into the ID and OD end wall definitions. So these are the main hub and shroud end wall locations that we discussed earlier. This yellow section does not include split flow definition. So we tell WAND the number of points that we have, as well as the axial reference location, followed by a listing of the X and R hub and X and R shroud point distribution. The next line here is the where we begin to enter our split flow definition. Again, we start with the number of points in our split flow definition, followed by our x offset. After that, we enter our core interface location. So we have our x and r location for the core hub, and then our x and r location for the core tip. Finally, once we have that entered, then we enter our our definition for the duct geometry. So an x and r location for each point we specified earlier. To fully generate the mesh, now that we have all of our geometry and prerequisites satisfied, we need to make sure our WAND file, splitter AGF file, and our downwind and upwind data files are all in the proper directory when we run WAND. Running WAND should produce a split flow restart file, as well as possibly some .leo input files. Currently, the .leo input files are not automatically generated, but they will be automatically generated in a future release. So once the split flow mesh is actually generated, you'll end up with something, a mesh that looks something like the picture on the left. So you can see the split flow mesh topology consists of 4 blocks. You can see we have the fan interface here on the left. This green block would be the interface with the core, and then this blue block would be the interface with the bypass. Again, this is a very zoomed in view, so we're only looking at a small portion of it. But the important thing to notice is that due to the mesh topology, the way it's set up here, we're able to avoid striping in the mesh. That leads to a lot of unnecessary mesh nodes where they're not needed, as well as some of the negative effects in terms of artificial flow resistance that can come from striping. So in the next section, we will go over how to take the mesh that we've generated and then run the mesh through Leo. For now, thank you.